So we talked about a thermometer measures heat intensity, not quantity. So what does measure quantity? That's going to be the BTU. And BTU stands for British Thermal Unit. You're going to take out your pen and paper and write that down, British Thermal Unit, BTUs. We use BTUs in HVAC exclusively and extensively. So in the summertime, we're going to do BTU heat load calculations. How much heat in BTUs is coming into the house? And our air conditioner needs to be sized in BTUs, how much BTU energy it needs to take the heat out of the house in the summertime. And in the wintertime, how much BTU the house has lost, a heat loss calculation. So BTU is going to be leaving the house, going to the air outside, and we need to size our furnace or heat pump to see how many BTUs of heat we need to replace or put back into the house. When we get the refrigeration, we're going to be talking about BTUs in different products, such as meat. We want to cool meat down. How many BTUs of heat energy is in that meat? How much BTUs is it going to take to move that energy out? So it's very, very popular in HVAC. It's used on almost every certification test, and it has a definition. So the definition is going to be the amount of heat or the amount of heat energy required to change 1 pound of water 1 degree Fahrenheit. That's the formal definition, and that's what you have to learn for HVAC. You have to know this, but it doesn't really have any meaning to you. So what we're going to do is apply some meaning to this, and then we're going to go into more detail about BTU. It technically has a formula. It's the temperature change times the pound of water equals BTUs, but we're going to get a little more into that shortly. So by doing this example, we have a scale set up. I have some pot with me. It's legal in this state. It's just a pot. And I have a little heater set up. And we have a thermometer and a scale. So we're going to start off by measuring this. So what I'm going to do is I'm going to put my stove on top of the scale. And we'll put this little adapter here so you can see what's happening. So here we can measure how many pounds is on our scale right now. So on the scale right now, we have a degree, but I don't want to take into account all of this. I want to zero this out. So we're going to be talking about scales more when we get into recovery, vacuum, and recharge. So I'm going to press the 0 unit out. 0, it's also called tare on some. Now it says everything that's on the scale is now registered at 0. I also have my thermometer taped in here. So I'm going to put this second meter on the side. And this is going to give us the temperature of what's going to be inside of there. So now we're going to add some water to our scale until we get 1 pound. So we can actually visualize what 1 pound is going to be. Oops. Went a little over, so we got 1 pound, 1 ounce, slightly over. And our temperature, we're going to put our thermometer inside a little bit better. Give it just a little bit of time for our thermometer to zero out, and we're going to have a nice starting point. So we're going to round this out to 38 degrees Fahrenheit. What we're going to now do is add heat energy into this 1 pound of water. So as we add heat energy into it, we want to raise this up to, so now we're at 39 degrees Fahrenheit. So we've changed 1 degree temperature, and we have 1 pound of water that equals 1 BTU. So that is 1 BTU of heat energy. Now let's see what happens if we keep adding heat. So I'm just going to turn this on and let this continue to heat up. So if we let this continue to heat up, we'll count 38 as our starting point. We're still going to have 1 pound of water on this whole example. But let's see what happens as we add heat energy. So now we're up to 39. So we still have 1 BTU of heat. Now as you can see, we're adding heat energy into the water. The temperature of the water is going up. So now we have a quantity and an intensity together. Now we can calculate an actual BTU number. So my thermometer that I have here is not quite the most accurate, but it's going to give us a good idea. So let's say that we get up to, for simplicity, 48 degrees. So if we're at 48 degrees now, we started at 38 degrees, that's a 10 degree temperature change, or a 10 degree delta T. So if we put 10 degrees here, 10 times 1 pound of water, that would be an example of 10 BTUs of heat energy. So don't be afraid of the math. It's just simply we're going to take some numbers to get an answer. And what I want you to do more than anything is visualize that BTU has meaning. It actually has something connected to it. Now we can apply BTUs to many things. For example, we can apply BTU to air. As we apply BTUs to air, air is going to be much lighter than water. So it's going to take much less BTU to change air. It's also going to depend on how much moisture is in the air, how dry the air is, how much humidity is in the air. Things like this are also going to play a part in that. When we start getting into refrigeration, we're going to cool many different products. We're going to say cool meat or cool poultry or cool water. We're actually going to literally be freezing water, which gets into a whole other category. Beer, for example, has a BTU rating. We take the heat out of that beer. We want it at a precise temperature. There's many, many different things we talk about when we're dealing with these BTUs. So right now we're over at 70 degrees. So if we take 70 degrees minus our 38 degree starting spot, what does that come out to?
Thinking backwards.
So we got 32 degree temperature change. So if we put 32 here, 32 degree temperature change times 1 pound of water, that's 32 BTUs of heat energy. You don't have to be great at math. I'm not great at math. We have a calculator now that's on our phones, which is great, cool. Use your calculators, do the math in your head, do the math on paper. Don't be afraid of the math. HVAC has tons of math involved in it, but it's just simple math. As we continue to add heat energy into this water, the temperature will change. Now the catch is, if I had twice as much water, it's going to change the temperature a whole lot less. So we're waiting on this water to warm up and change temperature. Let's look at a few other little different options. Let's say that I had 10 BTUs of heat energy, and I applied 10 BTUs to 1 pound of water versus 10 BTUs to 10 pounds of water. If I put 10 BTUs in the 1 pound of water, it would change the temperature of the water 10 degrees. It would be 10 degrees warmer. If I put 10 BTUs in 1 pound of water, it would change the temperature of that water 1 degree Fahrenheit. So the quantity of that water is extremely important. The same thing is with air. Air is going to have its own BTU rating. As I add BTU heat energy to air, the temperature of air will go up. But it's going to depend on how much air we're talking about. We're going to have our HVAC system that's pulling pounds of air through the house across its evaporator coil, and we're going to physically be taking BTU heat energy away from that air. So BTU is a very important part. Now if we can see we're adding BTU heat energy, the temperature of water continues to climb, we're at 142 BTUs. So we started out at 38, and we're now at 145. So we can just do some quick math. We'll take 145 minus 38, and that gives me a temperature change of 107 degrees Fahrenheit. We still have 1 pound of water. That's 107 BTUs right there. I want you to understand that it does have some kind of connection. So BTUs, or we're waiting for this water to heat up. We're going to continue to talk a little bit more about BTUs. So the question is, if it's BTU, is the amount of heat required to change 1 pound of water 1 degree Fahrenheit, does British and the rest of the world use pounds in Fahrenheit? And the answer is no. The rest of the world actually uses Celsius, and the rest of the world uses the metric symbol, the metric system for calculating weight. So America is pretty much the only country I know of that's still using BTUs, the British Thermal Unit. Britain has actually changed it. They have now using what we call the calorie, and most of the rest of the world are using calories. You see calories if you're talking about going on a diet. Well, calories is a heat energy or an energy rating. So calorie, the definition of calorie is the amount of heat required to weigh 1 gram of water 1 degree Celsius. It's a very similar thing, but the idea is that the metric system is easier to think about. If we wanted to talk about our tape measure, you have 1/16, and then you have an 1/8, and then you have 3/16, and then you have all your different numbers. I have to look at a tape measure. It's difficult to count, but if I wanted to count in the metric system, it's 1, 1.5, 2, 2.5, 3, 3.54. Now for me to transfer over to the metric system would be difficult because I've spent my whole life learning an imperial system. However, the rest of the world has made that change, and their kids are learning the metric system right now, and it's much, much easier. Don't hate the metric system. It's actually a very simple system to work with. It's just that we get used to our ways. I personally, since we're the only country still using pounds and Fahrenheit, we should call it the ATU for the American Thermal Unit, but Americans don't like change, so we're going to keep it to BTU. the British Thermal Unit. Anyway, that's just a little fun, worthless fact of where it comes from. Although knowing calorie is how they rate the metric system for BTUs, that is fairly important to know. So the next thing is we see that this water right here is actually starting to boil, and my thermometer is not accurate. It is showing much off. So water boils at 212 degrees Fahrenheit. Water is boiling at 212 degrees Fahrenheit. So we know that water boils at 212, so our thermometer is a little bit off, but let's say that we started out at 32 degrees Fahrenheit. And our water is now at 212 degrees Fahrenheit. How many BTUs does it take to change water from 32 degrees liquid to 212 degrees liquid? So we're just going to do a little quick math. And we're going to put in 212 minus 32 equals 180. So it takes 180 BTUs of heat energy to change water from 32 all the way up to 212 degrees Fahrenheit. Now the next thing we're going to do is we're going to continue to add heat energy to this water. As we continue to add heat energy into this water, we're adding heat energy, we're adding heat energy, we're adding heat energy. We're going to see the temperature of this water is not going to change at all. Everything we talked about so far, the changing temperature of water from 32 liquid to 212 still in liquid, is 180 BTUs. This is called sensible heat. And we raised that temperature pretty fast. Within a few minutes, we went from 32 all the way to 212. 212 is going to be our key number here. This is going to be what we call a saturation temperature. So all the way up until now, we had sensible heat. Water is boiling, changing state from liquid to vapor. You can physically see it boiling, but our temperature is still going to be at 212 degrees Fahrenheit. This is where we change. So in the last video we talked about sensible heat. We can measure sensible heat. Now we're going to talk a little bit about a different type of heat. We got our water to 212, although our thermometer is not measuring very accurately. I have some very old probes hooked to this new meter, so I should have got some better probes hooked up here. But the difference is we still have that 1 pound of water. We're at 212 degrees Fahrenheit, and we're adding heat energy into this water. Now we see it's boiling. It's changing state from a liquid to vapor, but it's boiling. It's still at the exact same temperature. We're putting BTUs of heat energy into this water, but the water is staying at the exact same temperature. So we got to think, let's move our probes over here so we're catching on fire. So we have to think, what if we put more BTUs of heat energy in? So let's take our torch over here. We're going to light our torch up and add more heat to it. So as we add more heat energy, let's see if our temperature starts to change. And even though our temperature is a little bit off, we're boiling faster where the heat's at, but it's still at 212 degrees Fahrenheit. Maybe we just simply need more heat. So let's grab another torch over here and let's light up the other side of this. Let's get this hot. Let's get this really heated up, right? Let's add some heat energy into this water, right? So we're adding tons of heat energy to it. This container is made of aluminum. Aluminum is really good at transferring heat, so it's transferring heat from the container and the fire on the outside to the water on the inside. We have the electric skillet on the bottom, adding heat energy to it. We're boiling very, very fast. But notice that we're still at our same temperature. We're going to be at 212 degrees Fahrenheit. We are still not heating up. Notice here when I put my flame inside how the flame changes dramatically. That's because there's steam coming off, and because the steam and moisture is coming off, we end up with actually less heat energy. So I'm having more heat transfer by putting it on the metal itself. So no matter how much heat energy I add to this water, it's still at 212 degrees Fahrenheit. But we know that we have BTUs of heat energy right here in this propane canisters. We know that we're taking electrical energy and converting it to heat energy. We know for a fact that we're still adding BTUs of heat energy to this water, and it's not changing in temperature. But we are for sure 100% adding heat energy to this, but it's not changing temperature. But we know that we're putting BTUs. So where is the heat going? Where does the heat go?